Okay, question 10 is a 3-marker. Okay, we are looking for the molar volume is the same for all gases, same temperature and pressure, which is a statement of fact. Use your knowledge of chemistry, suggest how the molar volume of gases could be measured and compared. So we're going to have to do a measurement and a comparison. So there's 2 parts to this question. If you just talk about the measured and you don't talk about compared, then I would expect the maximum you get was 2 marks. Similarly with the comparison. They're giving you some suggestions of chemicals and apparatus, and you have to choose what you would do with them. Okay, so we're looking to compare molar volume. So molar volume, just to be absolutely clear, is your volume divided by your moles. Okay, right. What we have here is a series of chemicals which could release gases. Okay, especially what we have here is acid and a metal above hydrogen, obviously in the reactivity series, to give us our salt and hydrogen gas. So that's a potential one to use. And we've also got our metal carbonate, and we've got an acid there as well. And that is going to give us our salt and water and carbon dioxide gas. They've also given us the idea that we could just use cylinders of them. So what we could do is set up a chemical reaction, release a gas, capture the gas, find out how many moles of it we have, and we could then work from there. Okay, so what I would say is we are going to have to first of all capture it. I would go with a gas syringe. And I would go starting off with using the balance to measure the mass of the gas syringe, plus a delivery tube and a clip. Okay, so the reason would be, say I had this in a conical flask. Okay, and the conical flask has delivery tube to the side, well, the glass bit of it, and then you hook on a plastic bit, your rubber tubing, and then that's attached to the gas syringe. Okay, now if you have a clip which you can use to clip off here, which is a common kind of thing to use, okay, then you can basically measure the known mass, the starting mass of the rubber tubing, the clip and the gas syringe. And then you set up your chemical reaction, fizzes up here, you get your, so that doesn't look particularly like a stopper, but you know what I mean. You get the gas produced down here, you then clip off this bit here, you will have a known volume. Since you have a known volume, you can then go to the balance, get a known mass, and now we can work out moles. So moles mass divided by formula mass. Okay, so you're going to do a kind of weighing by difference thing here. And then once you've got your moles, plug it in here with your volume, and that will give you your molar volume. Okay, and you could do this for hydrogen, you could do this carbon dioxide. You could also do it for using the cylinder of nitrogen, just releasing into the gas syringe. Measuring cylinder I'm not quite so happy about using. It would work really nicely in terms of capturing the gas because you just do displacement over water, just using downward displacement. If you've got your kind of tube coming in here and you've got your water all the way across and you've got whatever you're collecting it in, so measuring cylinder would be the one that I would expect. And you will get your gas kind of collecting in here and pushing the water down. But then how you actually measure the mass of that gets a little bit more complicated. You could obviously stick something in, a stopper in, but if you do that, you're still probably going to have water mass just inside the cylinder from where you've pushed the stopper in, various bits like this. So I think this is your best kind of bet to give you a nice, clean measurement. But as long as you have talked about it reasonably well, you know, you're looking for that. So as I say, measured, I would go with this. Compared, I would do several. So there we go. There's 2 different chemical reactions to give you 2 different gases. And we could use the cylinder of nitrogen. That would give us 3. Okay.